Everyone keeps telling you AI is intelligent, but intelligence isn't just about reasoning and about pattern matching. It's meaning, it's reasoning, and it's emotion. I spent 20 years building AI systems, scaled a company to 1,000 people, and I can tell you with complete certainty that every AI model or platform that you're using today only has one of those three, just one. And until we fix that, every product, every workflow, every company being built on top of AI is sitting on an incomplete foundation. A lot of what we're really seeing with the current state of AI is actually, it's a glorified parrot. It's predicting the next set of words. And what do I mean by that? If you take a step back for a second and let's think about something as simple as addition. So I could do 1 + 1, 3 syllables, or 3 characters, sorry. Or I could do ONE plus ONE, and that's 13 characters. They mean the same thing, yet one is 78% less characters than the other. And that tells you something really important. That language is not really a method of storing meaning, it's a method of synthesizing meaning. I could have said that to you in Hindi, in English, in Greek, the character count would have changed. What's interesting is that meaning is very different, and meaning is all about context. It's about the neighbors of that meaning. So imagine I take lots of addition, I get to multiplication. I take lots of addition, multiplication, division, subtraction, and I get to algebra. And then I do lots of algebra, I get to calculus. And so you're starting to compound meaning and compound knowledge to make new things. And you go down to the foundations of how a lot of this meaning was built. It's built on fundamental basics. Like we learned addition by putting bricks together. And what we have today with AI is it's really just brute force prediction. So as the models get bigger, they sound like they're being intelligent, but really what they're doing is over a very large amount of data set, they are effectively predicting what is the next set of tokens. And that's why you have this concept of hallucination, mathematically termed as confabulation, where ultimately it just got the wrong set of words that came next. And that is why it's so important to have meaning and reasoning. And meaning is fundamentally deterministic. It doesn't change, right? It's stable. Imagine if every single day you woke up and there was a different way of doing addition, or every single day you woke up, there was a different meaning for the word love. And no pun intended, like it would be a real problem. And this is really where the difference is between having a purely language-based model versus how humans think, which is symbolic, like we're pulling meaning and then we're reasoning around that. Intelligence is such an interesting concept. You've got a bunch of branches of it, right? So the first thing I think you have to break intelligence down into its 3 pieces. So you've got meaning, which is retrieval. We are not generating everything every time. We're pulling memories, we're pulling knowledge that we've already got stored. And the atomic unit of knowledge is not a word or a token or a syllable. The atomic unit of knowledge is actually a concept. So imagine that PDF you wrote or that email you've done or that conversation that you've had. The atomic units that make up that conversation are concepts akin to ideas. And it's a sequence of concepts that ultimately underpin any artifact. It could be a conversation, which could be a PDF, an email, a meeting, a broadcast. What's really interesting about a language model versus, say, a concept model, which understands meaning, is let's imagine this puzzle of the Serengeti. So you've got the sky, you've got the sun, you've got the trees, you've got the ground, and then you throw all the pieces on the floor. The language model tries every combination. So you might have the bum of a rhino connected to the trunk of a tree because the colors match, right, or some sort of proximity. But a concept model will say, oh no, that's an animal, meaning that's a tree, meaning those meanings don't have a relationship. Like there is no way to traverse the concept graph to go from one to the other. And that's really important because then it stops the hallucination. And when you really think about this from a macro perspective, having that atomic unit of knowledge and having meaning between those atomic units is really, really important. Now, one of the most important things about meaning is time, right? So language models are trained. And so they effectively have a bit of knowledge, or whatever knowledge they have is the last time they were trained. They don't know how their training was a week ago or a month ago or a year ago. Now we think about our own knowledge. Why is temporality or time so important? For one, you want to measure drift. So what do I mean by that? You kind of want to know, how has something changed over time, right? So for example, how have language models changed over time? So the original one was BERT, or even before that, Word to Vec. And then it's sort of gone over time and it's now become, billions of parameters. The other piece, which is really important, is propagation, which is about time. Like, how has something moved? We might be having this discussion and you might get a tidbit of information from this podcast. And then how did it transpire in a meeting tomorrow? And then how did it go from that meeting to another? Like, how did the knowledge enter your ecosystem? And then how did it move through? And time is so important because it shows how things have evolved, and it also shows how things have moved. Language models just can't do that. And so when you want to ask questions like, how has something evolved? Explain to me my relationship with X and how that's changed. They're trying to scrape time from the artifacts that they're pulling in without inherently understanding what time is or what the evolution of those things are. What if I told you that your AI is a glorified parrot with a spectacular vocabulary and absolutely zero memory? It doesn't know what anything really means. It doesn't know much about you other than the context of your own conversation. It doesn't even know what the time is. And no, that's not getting patched. Which is why I put together a 12-minute briefing on the architecture flaw that nobody's talking about and the neurosymbolic approach that actually addresses it. Link down below. So, one of the most interesting things that happened in AI was when ChatGPT launched. People say, well, that's when language models launched. No, language models have been here for a decade. What actually was the big shift was the design shift. Suddenly you had very complex software that previously you needed a PhD to build, run, work with, now looking like it's inside a WhatsApp or a text message experience. And so suddenly the design was much simpler. You weren't in a terminal firing commands, you were chatting. The second is that it sounded human, right? It had enough of a vocabulary to not only sit in a channel that was reserved for humans, text messaging, WhatsApp, but it sounded like a human. And so suddenly we were being tricked effectively from a design perspective. We thought it was intelligent, and then it would tell you wrong things. It would make up information. All it's trying to do is figure out the next set of words, and it got a statistical inaccuracy in that answer. And that is a confabulation, which is very different to how we've branded it. And as I say, this whole design and ontology of what we've said language models are, it's a lot of branding, right? The design interface, the fact that there's a slow echo, it feels like it's writing back, but also the fact that we're using terminology like hallucination versus statistical error or confabulation, which sounds more technical. One of the things that I've been really thinking about over the last year, it's sort of 2 or 3 different streams of thought. The average person is spending 3 to 4 hours a day searching. And in sort of the language model world or the current AI world, we're effectively using the language model to run a search query, to pull files, then we break the files up arbitrarily so that we can hit the token limit and not break the token limit. And then we're trying to synthesize around those files to get an answer. That's a hugely problematic, sluggish way of actually getting it done. And so we said, what if we could get rid of search and you just have to ask a question, get an answer? The second is we've sort of been really interested in this idea that as people start building agents, you can't have silos of memory. So you can't have your memory with Claude or your memory with OpenAI or ChatGPT or your memory with whatever agent you might have built. You kind of need the Google Drive of memory, but it also needs to know you, which leads to the third part of this, which is when you talk to an AI, when you go to a website, you're all getting the same content, especially in sort of the Web 2 world. What if when you talked to an AI or when you were on a web page, you were able to have your context interweaved into what you're reading? So it's picking off from where your knowledge left off. I'll give you a good example. You're reading an article, right? And let's just say it's an article on new energy sources. So if you've never done physics or if you haven't done math in a while, the article should be written slightly differently so that your knowledge can be built up through the article. So you're not spending then the next half an hour Googling words, researching, trying to figure out what things are. And so imagine if every single time you went to a web page, you talked to an AI, it could build from where your knowledge left off. And it knows that because it's mapped together all the concepts that make up your knowledge and linked to all of the text, the embeddings, which make up those various concepts in the various different artifacts, meetings, documents, and so forth that you've seen. And the net effect is you've built a second brain of you. And so that becomes really powerful because you're offloaded needing to remember everything. And we're starting to see this already, right? There's this thing called the Google effect, which is you no longer remember necessarily information. You remember how to get the information. A good example is Google Maps. Another good example is when you're sort of looking for things. You used to remember URLs or you used to remember the content. Now you went from remembering the content to remembering the URL to then actually just saying, I'll just search for it. And even if how we file, right? I remember when I first used Outlook or even Lotus Notes, you were filing things in folders. It was the whole physical world transferred into the digital world. And then you got search. And you're like, well, I don't need to file anything. I can just search for it. And now we spend a quarter of our day, a third of our day searching. And that's a huge cost. I mean, if you imagine an average person earns, let's just say $100,000 a year, an average knowledge worker, that's like $20,000, $30,000 wasted per person. And there's about 1 billion knowledge workers in the world. And so in Second Brain, we're really trying to build the shared intelligence layer between humans, AI agents, and teams of humans and AI agents, so that you never need to figure out where your stuff is. You never need to search. And then you can actually have really nice interfaces running on top from your own Jarvis or Quora through to building software that runs on top, making you so much more streamlined and more efficient, and making also sure that you don't do the same thing 50 times, 50 different ways. Or worse, you write X, then a colleague writes Y that contradicts X, which we see a lot of as companies become big. So we're still very early in our development. And one of the things that we've been doing is actually launching a design partnership program. So we've now got law firms, we've got construction, we've got communities, we've got a little bit around sort of social and venture capital, and we're about to do news and events. And so one of the most interesting things for us is we're starting to see massive amounts of repeatability. And across the Second Brain platform, you can build these vertical solutions that plug into the intelligence layer. And the power here is the ability for us to use our platform, to use one of the things built on our platform is called Kit, which allows you to be able to build agents and build classical software that runs on top of Second Brain, so that you can actually get really solid vertical solutions. A good example is a single pane of glass for a law firm. So everything about cases, clients, precedents, legal law, timekeeping, same thing applies to accountants. And then, we had a customer the other day that said to us, wouldn't it be great? We're about 1,200 people, 1,400 people, but we don't know what everyone does. It's really hard for us to find someone. Well, that applies in accounting, that applies in legal, that applies in any mid-sized, large-sized company. And so Second Brain actually allows, because we understand meaning, so we know what your profile means, right? We know what your CV means. We know what that case means. We know what that consulting project means. And because we're connecting these relationships between people, organizations, and then a whole bluster of concepts, we're able to actually generate you, hey, you should go speak to this person for what you're trying to do. So if you're a business that is really thinking about how you could use AI, how you could use agents, how you could actually transform the way you work, save cost, increase revenue, improve margins, give people a better work-life balance, like whatever the mantra might be behind what you're doing there, we're really interested in talking to you, because so far across verticals, we've seen something really common. There is a lot more volume of information that a company has that's highly repetitive, that's not that unique, but actually the golden nugget exists in the relationships of things that are covered in those documents. The benefit of a single pane of glass that goes across all the different systems you might have been using over time. So now you have a unified view of your business. You have a unified view of the shared intelligence within the company. So please come to secondbrain.ai, get in touch with us. We love to figure out, what is it that you're trying to solve? What kind of efficiency are you trying to gain? And what kind of optimizations you're trying to do, and then see if the platform actually works for achieving that.